everyone. Welcome to your geometry play posit for today. We're going to be covering quite a few lessons in your OMHS, mostly because some of them are review and some of them go really well together. So grab your notes, have your OMHS play posit graded assignment open, and let's get ready to go. Just a few announcements before we get started. This week is Science Week. You guys are going to find optional sessions every day of the week at 1 o'clock. We're so excited. We're hoping that you find something that you're interested in, or maybe something that you didn't think you would be interested in, but after going to the session, you were surprised with yourself maybe. The first one on Monday is Tessellations with Miss Popko and Miss Dorito. And then Tuesday, we have some poetry writing with Miss Robertson and Miss Jenkins. Wednesday, some women in science with some of our history teachers, Miss Cedar and Miss Waitman. Thursday, we have a dancing rice experiment with myself. And then Friday is our pet parade. So just take note, if you wanted to participate in actually creating a tessellation, then you're going to want to have these materials ready. A square piece of paper, small index cards work well, scissors, tape, paper A4 size, that's like your 8.5 by 11, and some pencils or crayons or markers. For the dancing rice experiment, you're going to want white vinegar, baking soda, instant rice. It has to be instant rice for it to work. A clear jar or glass, and some water. Food coloring is optional. Again, you can come to any of these sessions if you just want to sort of hang out and listen, but if you actually want to participate in the activity, then you'll want to grab those materials. Quick reminder, we have our pet parade this Friday. 7th grade is at 11 and 8th grade is at 1. All of these sessions will appear in your Class Connect schedule. So before we get too much further, I did want to just remind everyone that we have our first end date coming up, and that is November 6th. So this means after November 6th, you will no longer have access to retake any graded assignments that were assigned between the beginning of the year and this date. I'll put a square around that, November 6th. So this is our first end date. So I'm trying to kind of help you guys out well in advance. We have plenty of time to complete any missing assignments that you might have a 0 for some reason, review and retake any low graded assignments. And of course, as always, if you guys need any help at all, or if you have questions, you can reach out to me via email. But the goal is going to be to get everything done by November 6th, because after that date, we will not have access to those assignments. All right, here's our flashback for the day. They give you a conditional statement. It says, if an angle has a measure of 90 degrees, then it is a right angle. So this one wants us to state the converse of the conditional statement and determine whether it's true or false. I like to label these. Remember, our original statement we'll label as P and Q. And don't forget, the converse is the reverse. Right? So we're just going to switch the parts of the statement. We're going to flip the parts, the if and the then. So instead, it will be if it is a right angle. And you can say if it is, or you can say if an angle is a right angle, then the angle has a measure of 90 degrees. So all we did was flip the statement. So let's see which one of these matches up with that. If it is a right angle, so it could be this one, could be this one, and it's not these two, right? So now we have to decide whether it's true or false. So think about your definition of a right angle. Are right angles 90 degrees? Yes, they are. So it is true. It is A. So this is a question I pulled directly from one of the previous SOLs. So this is a question you can expect to see, a type of question. All right, so today let's get started with congruent triangles. Remember, we've talked about congruent before. The symbol is our equal sign with the tilde above it, or the squiggly. And it doesn't mean that the measure, or I mean, it doesn't mean that the shapes are the exact same shapes, right? Because you see here there are two shapes, but it means that the shapes measured are equal. So we have lots of markings going on. Remember, the markings match up. So this is saying that AB is congruent to DE. We don't know how long it is, but we know it's the same because it has the same tick marks. Think about what else could be the same. What else matches up? We have BC is congruent to EF, right, with the 2 tick marks, and then we have the side with the 3 tick marks. AC is congruent to DF. So each of those sides are congruent to one in one shape to the other. And then also look at the angle measures. We have one curve on the top angle, so angle A is congruent to angle D. And they're kind of small. Hopefully you can see on your paper if you printed the guided notes. These are 2 tick marks here. They're kind of tiny. Angle C is congruent to angle F. And then lastly, we have that right angle in there. Angle B is congruent to angle E. So you can see all the parts in triangle 1 have a corresponding part in triangle 2 that it's congruent to. And that's it. It's the side lengths and the angle measures. So congruent triangles, their side lengths are congruent and their angle measures are congruent. So let's put all of that together. There's a fancy acronym here, CPCTC, and that stands for, I'm actually going to type this, so that's probably better. Stands for corresponding parts of congruent triangles are congruent. I'm capitalizing every, there we go. Don't forget at any time, you guys can pause this recording and take notes or try things on your own. But CPCTC stands for corresponding parts of congruent triangles. So just what we got done, just what I got done showing you on that previous slide. Hold on. Let's bring this back down. There we go. Okay. Corresponding parts of congruent triangles are congruent. And the reason we shorten it is because, well, that's really long to say. And also, we're going to use this as one of our tools when we're doing those 2-column proofs. So a lot of times, mathematicians and you will just write CPCTC. And that means corresponding parts of congruent triangles are congruent. And all that means is what we did here. These triangles are congruent, so that means all the parts are also congruent. So here they give us what's called a congruence statement. A congruence statement. There's no picture. There's just a statement. Now we can definitely draw a picture. Let's draw a picture. I don't really know what these triangles look like. So when I don't know what they look like, I tend to just draw like regular old scaling triangles. We don't really know their side lengths. But I'm going to label this JAM and PET. You could really start anywhere with the labeling as long as you went in order as they appear. Okay, so the congruent statement is super powerful. The letters match up with what matches up on the diagrams. So letter J is first here and letter P is first here. That means those angles match up. Let's keep going. I'm going to grab a different color. Letter A is second and letter E is second. So that means those angles match up. They're in the same position in the congruence statement. All right, and lastly, we have letter M and letter T. So those angles are congruent. So I made those tick marks match. 3. That's why it's a very powerful statement. We can get the congruencies just from the order the letters are written. So we can do the same thing with the side lengths. So do you guys see how JA is written next to each other, J and A, and P and E? So that means JA is congruent to PE. So I made those tick marks match. We can keep going. AM is written in the same as ET. So AM, ET. And then lastly, JM and PT. First and the last, first and the last. So we can use this congruent statement to mark up our triangle. And then if you wanted to, why not? We can write our statements over here. Angle J is congruent to angle P. I'm just matching up what I marked on the diagram. Angle A is congruent to angle E. Angle M and angle, and angle T. And then we have the sides, right? JA is congruent to PE. And I pulled that off the diagram, but you can also pull it from here, JA and PE. Next is AM and ET. And lastly, JM and PT. Okay, so you're going to see it written where they give you the diagrams and you guys can pull off the congruencies. And then you're also going to see it where they give you the statement and you can write the diagrams. Or some people like to go straight to these. They just use the congruent statement. But I'm more visual, so I like to draw the picture, but it's totally up to you. And why is this so powerful? Let's look at one of these examples. Here they give us two triangles, and you have the congruent statement, but you also have the diagram. I'm going to mark up the diagram just because I think it helps visually. So XL is first, and XD. So XL and XD. They get the same tick mark. And then next is LW and DG. See, those are the next two, LW and DG. So that leaves the last side, WX, first and the last, and GX. Okay, got them all marked up. Now it wants to know, what is the length of GX? So we're looking for this guy. So because of this congruence statement, and because we marked the diagrams, it's really easy. We're looking for GX. We're looking for the side length that has 3 tick marks. Well, what does that match up to in the other triangle? 5.7. Remember, because of the congruent statement, we know WX is congruent to GX. And they both have the same tick marks. So that means GX is equal to 5.7 as well, because they're congruent triangles. So we were able, using this statement, this powerful statement, we were able to get the length of GX just based on how long WX was. And that's it. There's really nothing to compute. The math here that's involved is the geometric logic that we use when we're marking up the diagram from that statement. It's pretty cool. It's very powerful. Yes. Okay, so brace yourselves. We are going to learn 5 different ways that are going to help us prove triangles are congruent. There are 5 different postulates. Before we talk about the 5 postulates, we're just going to kind of go over some vocabulary. The first term we want to know is, what is an included angle? And then we're going to talk about an included side. And hopefully it's kind of intuitive. The name itself lends itself to the definition. But here's an example. Angle A is the included angle for, and it's included angle for side BA and side AC. So let's look at why that is. Here's side BA and here's AC. Where is angle A? Right in the middle. Angle A is the angle that's included in those two sides. Those two sides make that angle. So that's the definition of an included angle. It is formed by the two sides. It's where the two sides meet, where the vertex is. So let's see, angle B is the included angle for what two sides meet to make that angle. We can write AB if we want. Remember, you could also write BA. Doesn't really matter. And this side, right? CB or BC. Those two side lengths form angle B. So those are the two sides that have the included angle B. And lastly, angle C would be AC and BC, right? Those are the two sides that form angle C. You can kind of go the other way. Now we're going to see what two angles are between a side. So AB is the included side for, all right, here's AB, and it wants to know, ooh, that's fun. Yellow and blue make green, but it actually worked on the screen. That's cool. AB is the included side for which two angles? Well, I just highlighted them, didn't I? I went right over them. Angle A and angle B. Those are the two angles that form that side. So we would say angle A and angle B. They flank the side, if you will. And then BC is between angle B and angle C. And hopefully you're seeing the pattern. Angle C is between angle A and angle C. You guys are not going to have to regurgitate this in any form or fashion, like as far as the definition goes. We just want to have a working knowledge of what that means. Two angles are formed, I'm sorry, an angle is formed by two sides, and so that's considered the included angle, for example. It's going to help us when we talk about the postulates. So here's the first of the 5 postulates. Remember, a postulate is something that we take is true. And here it is. It's called the SSS postulate. And that stands for, and you guys can add this to your notes, that stands for side, side, side. And hopefully you can see in these diagrams that each triangle, all it has marked are the sides. So that's where it gets its name. If the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. And I know maybe you're thinking, duh, that's easy, but we just have to give a name to it. There are some triangles where this won't be true, right? There are cases when you have triangles where maybe only 2 sides are equal. I don't know, I'm just making this up. Obviously not drawn to scale, but maybe only those 2 sides are equal. In this case, in order for the SSS postulate to be true, all 3 sides have to be congruent. That's it. So actually, we're not gonna fill this part out because we just talked about all of this on the previous slide. I was just gonna list out the included angles and sides for these triangles, and I think that's a little bit redundant. Okay, so this is really nice because I love when the postulate's name matches exactly what it is. So one thing I like to do, you guys probably know this by now, is I'm a big visual person, I'm a big labeler. And if you are too, then I think this is gonna help you. So when we get to doing these triangle congruence problems, I think it's helpful to label what you have. We have a side here, and a side here. When you look at your second triangle, oh, we have a side, and a side. So the postulate kind of jumps out at you. What did we write? We wrote S, S, S. So it's just based on what the triangle has marked is what the postulate is. And you'll see some examples as we go through these. But let's get through the 5 postulates in our toolbox. Here's the next one, SAS. Side, angle, side. So this one tells us 2 sides and the included angle, here's that word we learned, of one triangle are congruent to the 2 sides and the included angle of another triangle. Then the triangles are congruent. So let's write what we have. We have a side marked. we have an angle marked, and we have a side marked. Over here, we have a side marked, an angle marked, and a side marked. So the postulate, again, I know it's written up here for you, but if it wasn't, it would jump out at you. We have SAS, SAS. Something I want to point out that's super duper important. You have to read the markings as they're written. So side, angle, side. We can't go like this. We cannot say side, side, angle. That's not allowed. You're not allowed to skip parts of the markings. Why can I not erase? Hello. Okay. You cannot skip the markings of the triangle. So if we were going to go side, you have to go to the one that's closest to it, which is the angle, right? We're not going to go, in this case, we would not go clockwise because you're going to end up skipping a bunch of things that are not marked. There's nothing there. There's nothing marked. So you want to go in the direction and when the markings occur. It doesn't matter if you start at the 1 tick or the 2 tick. That part doesn't matter. What matters is going in order of the tick mark. So let's see the next one. The next one is ASA, angle, side, angle. So we're going to add some markings to this picture to make it work. Look, angle marked, side marked, angle marked. Angle, side, angle. There's our example of ASA. We would not read this angle, angle, side. You see how that's not correct. You cannot skip parts of the triangle that are not marked. Okay, hope I'm making that sound very important because it is, because it will change your answers. You can see that that was a different postulate. That was angle, angle, side. That doesn't make sense. We need to start on one part, whether we can even start up here, and then go to the very next closest marking, which happens to be side. Angle, angle, side, angle. All right, our fourth postulate is angle, angle, side. I'm going to add another, we need to add these, they were missing. Whoops. Hold on. Okay, let me fix that. There we go. So we have an angle, and a side. Angle, angle, and a side. It is AAS. All right. We're going to recall the right triangle. So I know you guys remember this. Here's that symbol that it's a right triangle. And the side across from the right angle is always the what? It's always the hypotenuse. And remember the other two sides, we could call them legs. Doesn't really matter which one, they're both legs. So we just need to review those terms, hypotenuse and legs. So the cool thing about the next one is it's called the hypotenuse leg. So if you have the hypotenuse marked and a leg marked, you have the HL congruence postulate. It doesn't matter which leg, as long as they're the corresponding legs. All right, let's get into some. So here's the diagrams. It tells us to state if the two triangles are congruent. If so, how do you know? So I think let's write our postulates up here so we don't forget them. Side, 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 angle, side, angle, angle, side. Let's go through them. Side, 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 angle, side, angle, angle, side, angle, and HL. Okay, so I have two tricks for you. Tricks, not really tricks, but recommendations. I suggest always separating any triangles that are together. So like question number 1, actually 1 through 3. See how they're all stuck together? I think it's helpful if you separate them. So the other thing though that we want to do is to mark any vertical angles that we're allowed to. And then also we want to mark any reflexive sides because we're allowed. So if you look at number 1, do you guys see how there's a rectangle, right? But there's also 2 triangles, and the 2 triangles share the diagonal. They share this side. That's called a reflexive side. Remember we talked about the reflexive property. So when the triangle on the bottom looks in the mirror, it's looking directly at its reflection on the other side, and it's sharing that side. So whenever 2 triangles are stuck together and they share a side, you're allowed to mark the side because they share it. It's the same side. So now let's split up the triangle. And take the markings with it. Whatever markings were in the picture, take them with it. There we go. Now, I like to label, I think it helps. Let's label what we have. We have an angle, a side, side, and we have an angle, side, side. So I'm not trying to be inappropriate at all, but there is no angle, side, side postulate, right? There's none up there. There's also no SSA postulate at all either. Because you could read it the other direction, right? SSA, ASS. So this one, they are not congruent. It does not exist. So the current markings that exist on the picture do not show that the triangles are congruent. So we would say not congruent. Let's try number 2. Number 2 is also a diagram where the triangles are squished together so we can mark the reflexive side. We can separate them if you want to. I promise you I draw better triangles on regular paper. I promise. It's just a little tricky drawing on the screen sometimes. Okay, so we have angle, side, angle, angle, side, angle. It does not matter that they're sort of flipped. It doesn't, because you can read them in either direction. So this does match one of our postulates up here, ASA. So we would say it is congruent by ASA. You could say by the ASA postulate. That's like super fancy. But our markings match the postulate, so we're good to go. All right, let's try number 3. Ooh, I have that reflexive side again, that side that they share. I'm going to use 1 tick mark just because the other sides are marked with 2 and 3. So I'm not going to separate this one because I'm going to show you that you can also do it without separating. So let's just label what we have. We have a side marked, and a side marked. We have all sides. So hopefully you remember we do have a side, side, side postulate. So there you go. Number 4. Number 4 is the first one we've seen where they're not sharing a side, but this is the one where number 2 is going to come into play. We have some vertical angles. Remember, vertical angles are angles that share a vertex and are right across from each other like this. Just remember, vertical angles are congruent. They're equal. They're the same exact measure. We learned that last class. So I'm going to mark those with 2 tick marks because 1 tick was already taken. So you are allowed to add that marking because we know for sure that vertical angles are equal no matter what their measure is. So let's label it. We have angle, side, angle, angle, oops, it's down here, side, angle. Again, it's okay that they're in different order or different orientations. See, this triangle is basically just upside down compared to this one. So don't get too tripped up on the fact that ASA is up here on here and it's down here on this one. As long as the markings go in the same order with letters and as long as you're not skipping anything. Remember I said we wouldn't start here and go A, A, S. No, you start in one place and then you go to the closest marking. So this is the ASA postulate. Yes, by the ASA postulate. All right, don't forget that at any point, you guys can pause the recording. I know you're doing questions throughout that I've put in for you, but also you can pause the recording if you need more time on a screen to take notes. All right, let's try these. Number 5, the triangles are already split apart for us. So we're just gonna mark what we have. I have a side and an angle, a side and an angle. Let me rewrite our postulates up here. Sometimes it's handy to have those up until you start to memorize them, and I know that you will. Not so much memorize them, but you're just going to be using them so much that it's going to feel like second nature. Okay, this is AS. Do you guys see any two-letter postulates that have A and S? Nope, only HL, right? And we don't know that this is a right triangle. Would say that these are not congruent. Even though they look congruent, we can't prove that they are without any measurements. There's not enough information. You could also say that, not enough information. Any. Okay. Number 6. Remember to mark anything that you can. So remember we have the reflexive side that we're allowed to mark, and then we have the vertical angles that we're allowed to mark. So in this one, we have those vertical angles that they share. And a lot of times when anybody sees a right angle, they immediately think HL. That's not always the case. You still have to see what markings you're given and what markings you have. So we have an angle, a side, and an angle. We have an angle, a side, and an angle. So it is actually ASA. In this case, here's the right angle, so that makes this the hypotenuse, right? And the hypotenuse has no marking on it. So we can't use HL. So it's the ASA postulate. Okay, number 7. Let's get to marking and labeling. We have a side, we have an angle, we have a side. Here we have an angle and a side and a side. Okay, so this triangle is side, angle, side, right? Like if you were to read it as you've written it in either direction, side, angle, side. Over here, if we start with the A, we would go angle, side, side, right? That's the next marking. Or, well, we can't go to the right, right? Because that's, oops, that is not the closest marking to it. The S on the left is. Let me see if I can erase that. So this one's a little tricky. The triangles look like they could be congruent. One of them flipped upside down, but remember, we don't have bad words in math, so this is not congruent. All right, number 8. This is getting kind of fun. We're just going to label what we have. We have a side, 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 we have a side. Right? And they all have a pair. 1, 1, 2, 2, 3, 3. This is the side, side, side postulate. Pretty straightforward. All right, 2 more. Here we have that reflexive angle, I'm sorry, the vertical angle, the angle right across from itself, so you're allowed to mark it because we know that they're equal. And then let's mark what we have. We have a side here, an angle here, and a side here, side and a side. So it's SAS. Do you guys see it? I think marking it helps so much because it just like brings the postulate to life and like jumps off the paper at you. All right, number 10. Ooh, here's the reflexive side. It's stuck together, so we're allowed to mark it. And it looks like we have side, side, side here, right? All the side lengths are marked. So we have the side, side, side postulate. More practice. These look cool. So let's look at this one. These are stuck together, so we know we have the reflexive side. I'm using 2 tick marks here just because the 1 tick mark was already taken. Let's split it apart. We have this bottom triangle. That's a terrible triangle, but you get it. And then we have the top triangle. And I'm keeping whatever markings are in the picture. So usually with a right angle, we go to HL. So let's see if this is in fact an HL. Is the hypotenuse marked? Yes, it's across from the right angle. And then is one of the legs marked? Yes, either one. So yes, this is the hypotenuse leg postulate. Therefore, you could say therefore, that's fun to write. Look at this guy. So it's stuck together here, so we know we can mark the reflexive side. So let's see what we have. We have an angle, and a side. Angle, angle, side. So sure enough, that's the angle, angle, side postulate. As long as those letters match in the same order in each triangle, then you have that postulate. Remember we saw one up here, like this was the SAS, and we got that one for this one, and so they did not match, so they were not congruent. Plus, ASS does not exist. Two more. These are the last two. All right, so here we have number one. The triangles are stuck together again, so there's that reflexive side. So we have a side, side, here's an angle, here's a side. Now one could argue that since this angle is not marked, that we would not be allowed to call it A. But technically we are, because there's another rule at play here. This is a straight line, right? And two angles on a straight line add up to what? 180. So by definition, we know this one must be 90 degrees. Even though it was not written, by definition, you guys know that. Two angles on a straight line add up to 180 degrees, so that makes the other angle 90. So now we are allowed to call SAS postulate. SAS, SAS. Okay, let's look at this one. So whenever you have a right angle, it's a good idea to start thinking about HL, but just keep in mind it won't always be HL. I'm going to go back. Remember we saw the triangle here with a right angle, and it was not HL because the hypotenuse was not marked. So just keep that in mind. Here we have the hypotenuse marked, right? It's across from the right angle in both triangles. And we have the leg marked. Therefore, hypotenuse leg. Sometimes you'll see the hashtag sign to note the end of a proof. Postulate. Okay. So that's it. That's it for today. I'll see you guys on Thursday. The big deal for today's lesson was just remembering these 5 postulates. We're going to talk more about these next class on Thursday, HL. And then also that whole reflexive side business, right? Where you can mark that for shared side. And then also the vertical angles, how vertical angles are congruent. All right, you guys, have a great day. I'll see you Thursday.